Surface area. Example 3, we'll call it. Okay, so let's just do one where we have y's instead of x's. And we're going to get one that's just kind of funky in there. I should have this picked out for you already, but I didn't. Oh, let me pause it. All right, let's say we have the curve x equals 1/5 y to the 5th plus 1 over 12 y cubed. And we are going between the areas where y is between 1 and 2. And we're going to rotate around the x-axis. Okay, if you're rotating a curve around the x-axis, you got 2 poc. If you're going around the x-axis, your radius is going to be y. And then we have our arc length. So it's going to be 1 plus. In this case, our function is in terms of x, so we're going to call that x prime squared. So it doesn't matter what your function is in, it's always the derivative of your function and then squared. So if you remember from when we did arc length, these are just grizzly, but we're going to just have to do it, okay? So x equals 1/5 y to the 5th plus 1/12. Remember, we got to change that to y to the -3 so that we can do our derivative. Derivative, bring the 5 forward. It cancels. You're left with y to the 4th. Plus, bring the -3 forward. You get negative. And when you subtract 1 from your exponent, you get -4. You have a 4 on the bottom because you had 3/12, which gives you 1/4. Okay, so that's my derivative. I think it's easier before I work with it, like just me personally. I think it's easier to write that negative exponent. I think it's easier just to go ahead and move it. So I have 1 over 4 y to the 4th. Those 4 y's are down there in the bottom. Okay, that's what I have. And then it says I have to square it, which means multiply it by itself. So y to the 4th times y to the 4th gives me y to the 8th. Y to the 4th time. Now remember, you can't just square the first term and then square the second term. You're foiling here. If you have to, write it out. But I would end up doing outsides and insides. So you're going to multiply these two together. Well, the y to the 4th cancel. And I just am left with -1/4. That will happen when you do the outsides. It will happen when you do the insides. And then I do the last terms times the last term. Now I'm not showing it here. I'm assuming you know what I'm talking about by foiling. Just write it by itself. So I get plus 1 over 16 y to the 8th. So when I simplify it, I have y to the 8th minus 2/4 plus 1 over 16 y to the 8th. That's what I get when I square my derivative. So that's what I have to plug in right there. Okay, so I got 2 poc. I have this variable y, because that's my radius. Square root of 1 plus y to the 8th minus 2/4. You can reduce that fraction if you want, but I'm thinking I might want it in fourths. So I'm going to leave it. Plus 1 over 16 y to the 8th. Okay, you've seen this before. I can't tell you enough. Please know it's going to be set up. You will be able to add those two together. 2 pi square root of y times the square root of. When you combine those two, I have y to the 8th. 1 minus 2/4 is plus 2/4 plus 1 over 16 y to the 8th. You will have a perfect square. They have set it up for you. This thing factors. It is a perfect square. And it factors as y to the 4th. So it's the square root of the first term, square root of the last term. Square root of 16 is 4. So I have 4y to the 4th on bottom. If I multiply that thing by itself, I get what's sitting under the radical. And when you take the square root of that, which is what I have in the formula, the square root and the 2 cancel. It will do it every time. Oh, let's move the surface area. Let's move this up. So, now let's look at what's left and be careful. So we have 2 poc. We have the letter y. Our radical canceled, so we're left with y to the 4th plus 1 over 4 y to the 4th. Okay. I do not have an exponent here, which is good. that means I can distribute that y. If I had an exponent there, I'd have to do some kind of funky u substitution thing. But I just have, I don't have an exponent, so I can distribute 2 pi times, this gives me y to the 5th. Now, I have a y to the 1st over, I got 4 y's on the bottom. One of your y's are going to cancel, and you'll have 4y to the 3rd left. Oh, my dogs are freaking out. Hold on. We are ready to do the antiderivative. Add 1 to your exponent. Get y to the 6th over 6. And, oh, you know what? Before we do that, we got to rewrite this thing. I forgot where I was after my dog rodeo. So all I mean by that is you still have your little 2-poc. You have y to the 5th. Before we do antiderivative, you need to rewrite this thing as y to the negative 3 power so that you can get ready to do the antiderivative. Do a big old scoot. All right. 2 pi. Oops, I don't need that anymore because I'm going to do the antiderivative. So that gives me y to the 6 over 6. Add 1 to your exponent here. I get y to the negative 2 divided by your new exponent, which is negative 2. Okay, so I have y to the 6th over 6. That would give me negative, I'm going to have 8 on the bottom. And so actually the y squared is on the bottom, so I have 8y squared on the bottom. And my boundaries, oh shoot, I forgot what my boundaries were. Oh, my boundaries were 1 and 2. Okay, and then don't forget about 2-poc out here. So when I plug in 2 to the 6th power is 64, so I get 64 sixths. And when I plug in 2 in my second fraction, I get 1 over 32. Gross. Okay, subtract what you get when you plug in 1. That gives me 1/6. And minus 1/8. All right. So I have a lot of ridiculousness I'm about to have to do involving just, fraction stuff. But I'm going to combine the 6. That gives me 63/6. I can reduce that, which is nice. I'm going to go ahead, 1/8 is 4 over 32. So, but don't forget, it's minus 1/6, but it's going to be plus 1/8, which is plus 4 over 32. So when I combine negative 1 over 32 and positive 4, I get plus 3 over 32. Let's reduce this thing, because I'm going to have to get a common denominator, but it would be easier if I would reduce this. So I can divide them both by 3. Looks like I get 21 halves plus 3 over 32. Common denominator is going to be 64. So 21 times 32. Oh man, I don't even have a calculator. I got to do it old school. Old school up in here. Let me just take this opportunity while I'm doing this to tell Mullins that we all hate you for being at the beach. But a shout out to Huffy, who's apparently there with you. Huffy, don't help him with his calculus. Make him do it on his own. All right, 672. Oh, a shout out to poor Schwubby, who's sick. 672 over 64 plus 6 over 64. So that's 678. This is gross. Over 64. There's all kinds of stuff you can cancel out of this. Oh, you know what? I didn't even have to do that. I could have just had 32 for my common well, who cares? So divide them both by 2, I guess. So I get 329 over 32. And I think that's all I can do. Now, I have that 2-poc still. So times 2-poc. The 2 and the 32 will cancel. So I get 329 over 16. I feel like I've made an error in here. But I can go back. If so, it's with this fraction stuff. Oh, I see it now. That should be 339. I don't have a calculator, and my mental math was bad. So 678 divided by 2 would be 339. And when you separate the 2 or divide the 2 out from the 2-poc, it should be 339 pi over 16. That's what you get. That's your surface area, and that's it.